Hello and welcome to the Math Studio. In this video, we're going to prove cos alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. And this is a proof that's based on two things. It's based on the distance formula and it's also based on the cosine rule. So what I'm going to do first is I'm just going to draw just a quick diagram just to assist the explanation. So this is of course not the scale. Okay, it's quite a crude diagram. But what I'm going to do now is I'm going to draw a triangle that's inscribed in a unit circle. Okay, so there's my triangle there. I'll call that point A, and I'll call this one here point B. So you can sort of just pretend there's a unit circle around it. Okay, so centered on the origin. Okay, now let's make the angle OB from the positive x-axis. Let's make that angle beta. It kind of sort of works out well. Point B is angled, beta, radians or degrees from the positive x-axis. Okay, and OA is angled alpha. Okay, alpha degrees or alpha radians from the positive x-axis. This means then that the angle inside the triangle, so angle AOB, okay, so that's this angle here, this would be the difference between angle alpha and angle beta. So this would be alpha minus beta. So that would be the angle in there. Now, because the triangle is inscribed inside a unit circle, OB and OA are 1 unit in length as well. Okay, and that'll sort of make the calculations much simpler. Okay. Now, the other thing that we need is to note down the coordinates of point A and point B in terms of alpha and beta. So any point on a unit circle can be expressed in terms of the angle that the ray makes with the positive x-axis. So OB, okay, the x coordinate will be cos of beta. So if you sort of pretend there's a right angle triangle there, OB would be a hypotenuse. So the adjacent side would be cos of beta. And the opposite side here, so this is the y coordinate of B, that would be sine of beta. And likewise for point A, its coordinates would be cos of alpha, comma, sine of alpha. So now we have what we need to actually set the algebraic part of this proof up. Okay, so we need the length AB. And there's two ways that we can work out length AB. We can work it out using the distance formula, so it's Pythagoras, based on Pythagoras' theorem. Okay. But we can also work it out using the cosine rule. So that's what I said earlier on in the video, that we sort of have to use both ways of working out the same length and then effectively equating the two, and you sort of end up with this expression or this equation. So let's start this off. So by the distance formula, so length AB, I may have to use the other side of the board, so let's just see, I'm probably not going to be able to squeeze it all in here. So length AB, well, let's say AB squared in fact, by the distance formula, because I'm not going to use the square root here just for simplicity. Okay, so by the distance formula, recall the distance formula, x1 minus x2 all squared plus y1 minus y2 all squared, okay, is equal to the square of the distance. So AB squared is equal to cos of alpha minus cos of beta all squared plus sine of alpha minus sine of beta all squared. Let's expand that and see what happens. So we end up with cos squared alpha minus 2 cos alpha cos beta plus cos squared beta plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. Now some of this is probably starting to look a little bit familiar. The cos alpha cos beta, that's it up there. So hopefully you can start to see this proof taking shape. Now, there's a few things that we can simplify here. So you notice that there's a cos squared alpha and there's a sine squared alpha. There's also a cos squared beta and a sine squared beta. So cos squared alpha plus sine squared alpha equals 1. And likewise, cos squared beta plus sine squared beta also equals 1. So we could in fact eliminate that, all the squareds basically, and replace it just with the number 2. So that's equal to 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Okay, so let's call that equation number 1. So what I might do is on the reverse side of the board, I'm just going to continue the proof. So actually I might just write that again. So AB squared is 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. And that was equation number 1, if you recall. Okay, now we need to work out the distance AB, but this time by the cosine rule. So going back to our diagram, okay, so cosine rule, okay, if you recall the cosine rule, so it's, could be written many different ways, but A squared equals B squared plus C squared minus 2BC times the cosine of A. Okay, so here's our angle, that's our angle A, so cos of A, so it's alpha minus beta. And these are our two sides, so that this will be the included angle. And the sides, OA and OB, are just 1 each. So, okay, so let's do that. So by the cosine rule, okay, we have AB squared is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of alpha minus beta. And alpha minus beta is the angle inside, the included angle in triangle AOB. And of course we can simplify that, so 1 plus 1 is 2, and that's going to be 2 minus 2 cos of alpha minus beta. And this is equation number 2. Now we can equate 1 and 2, since they're both equal to AB squared. Okay, so I'm going to start off with equation number 2 because I want the cos alpha minus beta on the left-hand side. So let's do that. 2 minus 2 cos of alpha minus beta is equal to equation number 1, since it's the same distance, it's exactly the same interval, so but they're just expressed 2 different ways. That's why I like this proof. It sort of shows you there's multiple ways of achieving almost the same thing. Minus 2 sine alpha sine beta. Now we can subtract 2 from both sides, so that's nice and convenient. So that disappears. And we can also divide everything by -2. So that's also nice. So if we just divide everything by -2, okay, all terms by -2, and what do we end up with? We end up with cos of alpha minus beta is equal to cos of alpha cos of beta plus sine of alpha sine of beta as required. Thank you for watching.